Hello everyone. Welcome to MRU E-Learning powered by Malla Reddy University. I am J. Sophia, working in AIML department as an assistant professor in SOE School of Engineering. So today we are going to start the topic on data mining. So contents are what is data mining and KDD process and then data mining functionalities. So today what is data mining, KDD process and functionalities we are going to see. So data mining, what is mining? Generally we all know about a coal mining and a gold mining. So it has been digged from underground. So here also we are going to take the data from a bulk of or a large data set. So here you can see the line, it's from the large data sets. So it is stored in the data warehouse. So first of all, the definition is data mining is the process of extracting. So extracting from hidden, actionable insights, patterns and trends from the large data sets. So using what? Using what we are going to extract it? Using statistics, AI and machine learning and etc. So it is also we can define as extraction of interesting patterns or patterns in the sense we are able to do it using some functionalities. So knowledge from huge data. So you can see once again, extraction of interesting patterns or knowledge from huge amount of data from data warehouse. So this data warehouse which consists of the large data. Okay. So the other name of data mining is called as knowledge discovery mining in database. So knowledge discovery in database, it is also called as KDD. And also it is also called as business intelligence, also called as pattern analysis. So there are other names of it. So we are going to see what is KDD process here. KDD is also called as knowledge discovery from data. So it is a process where it is coming from the steps cleaning, integration, selection, transformation, mining and visualization we are saying. These are all, you see these are all pre-processing steps. So here you have a diagram where it consists of first one, the diagram you can see the steps. It is going to operate it from the bottom to top. Bottom to top. So from bottom to top we are going to come here. You see this diagram. First level, what we are going to do is we are going to collect the data in a database or in a different flat files. And then what is the next step? Well, you are going to collect the data and transform it and store it in data warehouse. We are going to clean it. Cleaning and integration. Cleaning and integration means removing the noisy data and missing values, finding out missing values. Like this, we are going to data clean and integrate all the different files which are there, all multiple files, combining all the multiple files. So integration is this one. So we are going to clean and integrate and store it in the data warehouse. And then here we have from data warehouse to data mining, we have a selection and transformation process or the steps we can say. So selection, what is selection means? What is the task you are going to do for data mining? Or for analysis, what is the task? Okay, so selection, task selection, and then you're going to transform it and you're going to understand it. For your understanding, you're going to transform it and then you're going to do the data mining. So next step here, you're going to see evaluation and presentation. Evaluation. So on the data, what we have selected and transformed, we are going to do evaluation and presentation. In this form, you see, we have here patterns, the graphs. There are different graphs, there are different patterns here. So you see the graphs are a curve graph, bar graph, pie chart. We all know in data visualization, these graphs. So in a different patterns, in different analysis, we are going to see. So that is what finally we see here in the diagram. Knowledge. This person is holding a tools means to do all these steps, whatever the steps are there here. To do these steps, we are going to use some tools here. different tools to extract the knowledge from the data. Okay, so this is what the data mining as a step in the process, okay, of knowledge discovery. So that is called KDD. So this is all how the data mining and analysis is going on. So next topic, data mining functionalities. This is also called, the other name of data mining functionalities is also called the kinds of patterns. What are the kinds of patterns, or what is data mining functionalities? Your data, whatever we are going to do it mining, data mining functionalities we use. Concept, class or class, description is there given here, characterization and discrimination it is given. You see here, concept or class, description it is given. This is one functionality. The other word or the other name we can give for this one is called generalization. What is generalization? Generalizing. Okay? Identifying the characterization or the characteristics of the data and discriminating the data, means here biasing. So we'll go one by one here. So next we have another topic is functionality mining, frequent patterns, associations and correlations. So next one is classification and prediction. Next one is clustering analysis. Next one outlier analysis. And the last one is evaluation analysis. And you see there are other functionalities also included. And next one, we are going to see each topic functionalities here. So here, class or concept description is also called as generalization, as I said. So here, data can be associated with classes or concepts. Based on the class or a concept, we are going to collect the data here. And described based on the class or concept means, you see flowers are there. In a flowers, again, if you're collecting the flowers, if you take a class as a rose, rose are different types of roses. Iris is there. Iris flower also has 3 types of iris flowers. So what are the different labels we can give for one flower is also class or a concept. On what basis, on what concept you're going to do or collect the data is a concept. So these descriptions can be derived via two parameters. Those are characterization or discrimination. What is characterization? Means it is a summarization of the general characteristics or features of a target class. Means here we are going to characterize the data and summarize the data based on the features of a class, targeted class. So here we use for characterization OLAP operations. In that OLAP operations for summarization we use roll up, drill down, like summarizing means compressing or making it a consolidated way. So here we are going to use OLAP operations, in that one roll up. So for characterization and summarization way, we are going to do that. Next one, data discrimination. Data discrimination, we all know what is the word meant by discriminating. Discriminating, it is called here bias. So data discrimination is a bias when a data set or a source is treated differently. So we are going to segregate the data or bias the data here, and then intentionally or unintentionally, you see we have the different data types. In a different data types also, here nominal, ordinal, numerical way it is going to be collected. The data is going to be collected. Again, in the nominal, numerical and ordinal data, we are going to segregate the data or the bias the data. Okay. So here next mining functionality helps. This functionality helps to, means data discrimination functionality helps to peculiar data sets. Means helps to separate peculiar data sets. What are the different data sets? We are going to separate it based on the ambiguity in attribute values. What is meant by ambiguity is unclear. What are unclear attributes, or what are the attributes which are clear and unclear, or in that way we are going to separate. So this is what generalizing the data. We can generalize the data based on the class or concept. In that, characterizing the data and discriminating the data. So next topic in that functionalities, we have mining frequent patterns, associations and correlations. This is in what way we can say is data mining functionalities. I want to find a relation of data, a related information which is there here. I want to find means here we have mining, frequent patterns, association. We all know what is the meaning of association. Association meaning is relation, or what is the relation between the two data sets or two data items. So here we are going to find based on the frequent patterns, frequent item sets. What is frequent patterns or frequent item sets means here what items are frequently purchased together. We are going to check there. We use some words, frequent item sets, frequent structure, frequent substructure, frequent subsequence. So what are frequently occurring items, data items? We are going to use this word there. Then next one. So in that way we are going to do the analysis. So what is association analysis means? It is a set of items that generally occur together in a transactional data sets, which are occurring together. We are going to check. That is association analysis. So here again we have two parameters that are used for association rules, that is support and confidence we say. So rules are association rules, if implies then we say, and then measures based on the support and confidence we are going to measure the relation of data items. Okay. So next one, using this algorithms a priori FP growth ECLAT algorithms, we are going to analyze the data and find the relation of the data. Next one we have here, in what applications we can use is marketing. Mainly there is an example given in the syllabus or subject is market basket analysis. So which items are frequently occurring? So marketing on fraud detection, credit card fraud detections, medical side we can use. Next one, classification and prediction. What is classifying? Classifying based on some category or a label. So here we say classification is a label prediction. Here in the classification we also call it as supervised learning. Okay. So supervised learning, in the sense, what is supervised learning means? It is a labeled data. Here also it is based on the label. We are going to classify the data like banking, loan data, like that. Next one, whatever the data is there available is the trained data. Another new data you want to check, it is a testing data. So prediction, that is called as here. So next one, what are the typical methods we use for classification algorithms are decision tree, Navi-based classification, support vector machine, rule-based classification. There are so many algorithms we use for classification. Based on the analysis what you want to do, you're going to use those algorithms. So typically in what applications we use is credit card fraud detection, direct marketing, classifying the stars, different stars and diseases, web pages. Okay, next. We are going to see the next functionality, cluster analysis. So cluster analysis, as I mentioned, classification is a supervised learning, means based on the class label we are going to classify the data. Here based on the, where there is no class label, means which is unknown. That is called as unsupervised learning. So here we are going to group the data to form new categories. That is called as cluster. Cluster analysis is grouping the data to form a new category. So example, cluster houses to find distribution patterns. What is meant by clustering here? As per this analysis, we can say how we are going to group the data is maximizing intra-class similarity and minimizing inter-class similarity. What is maximizing intra-class similarities? Means which are having the similarities more. The data items which are having similarities more, or the distance we can say. We will measure this clustering, or we can group the data using distance formulas. Okay. So we have different algorithms and methods and applications here. We use partitioning method. We use hierarchical methods like k-means, k-meroids for partitioning, and here hierarchical AGNES, Diana, like that names are there here, and grid-based and density-based, etc. There are so many algorithms we use for cluster method or clustering analysis. And next functionality is outlier. So as I mentioned, cluster analysis means grouping which are having similarities. So which are not having the similarities, or you see a data object that does not comply with the general behavior of the data, means which are not having the similarity for the cluster, which lies outside the cluster is called outlier. Okay, so which are, means you see here we are giving a word for that one, which are staying or which are being called as outlier is noisy or exception. So those are called as outliers. So one person's garbage could be another person's treasure. Where methods we are using for clustering and outlier are method by product of clustering or regression analysis. So here parametric methods, non-parametric methods are there, and here where we use this outlier analysis is we use it for fraud detections and rare events analysis. And the last functionality, as here we mentioned, evolution analysis, it refers to the data study of data sets. We are going to study the data sets that may have been through a phase of transformation or a change. So based on the evolution, means based on the generations to generations, we are going to capture the evolutionary trends and evolutionary trends in the data, which further contributes to the data characterization. What is the type of a data we are going to identify here, and classification and discrimination. So what we are going to do in the evolution analysis, based on the trend of data, we are going to contribute type of functionality here. So these are the functionalities for different analysis. What kind of analysis we are going to do? For that type of analysis, we use different functionalities. Thank you.